The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of Hawaii Tracker, bringing guys another volcano update. Today, Kilauea, Maunaloa, and a little bit of Samoa, as we've been doing the past couple weeks, courtesy of the USGS HVO's reports. So today is Thursday, September 1st, 2022, we will go through the usual paces for you guys. Danny, got anything you want to throw in here at the top?
No, I mean it's kind of the standard thing that we've been going over. The Kilauea has been pretty consistent, but the cool thing this week is being able to get some really quality footage of some resurfacing that took place inside of the active lava lake of Maunaloa, which is we're going to go over thanks to our friends over at Two Pineapples. We appreciate that. So yeah, we're going to go through that, and Phil's going to be able to really talk about it and show you exactly, that whole process a little bit. So yeah, excited a little bit about that.
Yeah, I think there is the lava lake. Lava lake's actually active as it has been, and then there's also a big ooze-up flow that we saw beginning last week, and I think it was a big ooze-up flow they caught on that north side of the crater that we'll see come up in the webcams too. So that's it was great viewing this past week. And it was caught on camera, so we'll spend a little more time sharing that since we have it. And otherwise, our show has been running a little long because of Samoa, so we'll just try to work our way through as usual. And a little bonus today at the very end, we'll go into a little bit of the crazy time zones of Samoa. and the history of changes and the date lines right there. And anyways, it's pretty fascinating. And just because in the context of wondering when something's going on from these reports, you might want to know what those dates actually are. So a little bonus at the end there. So unless you got anything else, Dane, I'll jump right into it.
No, that about gets it for now. I'll jump in a little bit later.
All right. Treats, thank you. So starting off here, summarizing Kilauea this week. Here's a recent photo of the summit area from the USGS. We have that main active lava lake. It's that silver pad right in here. And the main vent itself is right here. This, you can't really see it through the fume, but it's kind of lined up here, the vent and the lake, just so you can have an idea of the orientation. And we have this inner pit that's filling with lava, and all the way onto this down drop block over here on the side of the crater, right? So there's several of these collapse features that were formed in 2018. They came down from that previous crater floor, and lava's been filling in, and it's been overlapping them. And we'll come into this photograph a little bit later to see how high up it's actually come. So just a good check-in visual, since we haven't had a picture like this in a little while. And let's move on and show you guys a capture that Dane pulled off the KW camera this past week. And this, if I go to the date here, August 28th in the morning, that's that morning that we have the Great Lava viewing from. So the viewing area that we'll catch two pineapples from is back over here somewhere, and they're looking back in this direction here, and then they're also looking off to the side. Pan it over, you'll see this big ooze-up flow that occurs. So I really like this one because we'll see this from the other angle in the viewing summary here. So mahalo, Dane, for pulling that out. And it really gives you a good perspective of how big these ooze-up flows have been when they occur around the crater perimeter here, compared to the main lava lake size, which is just very, very slowly shrinking. And the big ooze-up flows can often they seem to kind of feel like a moat around the edge of the crater, but they can often take up, it seems like, I don't know, maybe not quite a quarter of that crater perimeter, but up to perhaps maybe, a tenth to a quarter, something like that. So big flows. And to really show you guys what that looked like in perspective, let's show you guys first the daytime view. And so here's a view from KW camera showing that summit, similar to what we're looking at from that first photograph. The big difference, if I zoom it in, is that we have the vent and the lava lake are a little bit more offset here than they were in past, right? If you look at this photograph, you can see it more easily. The glow from the vent and the lava lake, a slightly different angle from that previous photograph. So in any case, here's what the last week looked like on the KW camera. So the persistent lava lake in the middle, the ooze-up flow coming in here on the left side of the screen. That's the north. North is that way. And you can see it's looping again now. That one big surge started off in the northeast. It flowed almost all the way to the northwest. Persistent low-level activity continuing for a while afterwards. And that's mostly it. If I zoom it in, a little bit of oozing here in the foreground on this west side of the crater. This is the spot where we had the ooze-ups last week. And a persistent lava lake is just chugging along, not really any major change visible, especially from this angle. So cycling through our weekly summary here, let's look at the S1 camera reverse angle. So the ooze-up flow is popping in up here in the upper right, while the persistent lake is visible here in the middle, and the west vent complex over here on the left. Well, the biggest ooze-up flow is most of the movement we see in this video clip here. Otherwise, it's just a usual circulation in the lava lake. And in these week-long views, it's harder to actually see these long-term changes, but you can see the small southeast pit pad. It seems to be shrinking smaller and smaller every week we show this animation. So it seems to be resurfacing and very slowly shrinking as it hardens on the edges and kind of closes off that space. So we'll keep an eye on that. We're still seeing glowing vents elsewhere along the edge of this central crater floor, the part that's the most buoyant and it's been uplifting, and the ooze-ups come from below that. There is that glow spot right there, and these spots are ones that often are fuming, putting out gas and causing discoloration on the lava flows that are in place there nearby. Well, that, just minor changes in the last few weeks here, but just to make sure we review the last week, here is the f1 camera. So in this case, we only catch the very edge of this Ooze-up here on the left, a little bit over here again. Mostly it's off screen. And we see a little bit of these Ooze-ups in the foreground in that same spot from last week, which is interesting, right? That activity can persist for a while, and it shows you there's still injection happening there below this crust. And otherwise, the main lava lake is not really changing a whole lot. It's hard to see any real variation in the depth of the lake here, which is something we've looked at in the past. This pinkish margin between the dark blue and the orange, right? That's fairly constant width here. And we can see our southeast pit from this angle with this separation point growing as this lava surface contracts, closes up. That is mostly it. You see the west vent fuming, you see other hot spots around, but not a whole lot of change on Kilauea. Really just a one big ooze-up flow, and we'll continue advancing through to look at that. But just to make sure we're bringing everything current, some more current views. Just flashed one on screen. Lava Lake was much as before, and then now we have this view is a little bit more gas blocked, so it turns out this magenta color here. So, but otherwise, Lava Lake is still present and as before there. So turning to the S1, there is a view from a few hours ago, and let's see if I can reload it, if it'll show me some fog. And there it is, a little hazier than before. That's something we've noticed, and we'll come to here shortly, is there has been fog in the area recently. There's a V1 from a little earlier this afternoon. And let's reload it and see if fog is blowing in a view of here too. So certainly a little more foggy. And in this case, you can see the wind direction being illustrated by the plumes of fume here. So, looking at the V1, let's look at the last week. So there it is, and it'll loop as usual, and going through day and nighttime. You can see the different views depending on the lighting, ambient lighting there. And everything is still the same as before, coming in from this west area and three main sinks. There's an eastern sink, there's what I've been calling a northeast sink, and a southeast sink over here, where it goes through some quasi-lava tube into the southeast pit and then sinks again down in here. Now there seems to be a secondary fourth one, which is, maybe I'll call it this southern area right here, the southern sink, where sometimes this lava surface, as it's coming this direction, it's kind of rolling over like this, and so you actually can have it sinking in areas around here too. And so I point that out because we'll see the spatter on the video from Two Pineapples coming up. So that's our V1, not a lot of variation there, but you can see these long-term features. And I was just thinking today about how, all the old accounts we read from Jagger and Perret, these are the features they would call the grottos, right? These areas where the lava goes down and the gas doesn't want to go with it, so it comes back up and it bubbles and spurts and splashes, and all that stuff is falling on a ledge, on a rim, and it builds up this feature, this mound right here, right? That we've sometimes called spatter mounds. If they're linear, they can be like a rampart, usually has to do with a fissure. But in the old days, they would call them grottos because they look like little caves where the lava is going into, and they hang down with little lava sickles, stalactite-looking things, right? That hang as the lava splashes on the ceiling and just drips and drips. We've got some old videos of that from the 2018 or 2017, 16 era from Maunaloa. Maybe someday we'll pull it out again, but that's just something that I thought I'd share here, a little peek back in the history of the terminology of how these things go, right? It's always hard when you read those old accounts to think about everything happening in full color and see the orange and the bright, because everything is drawn in black and white and hand illustrated. So, and the photographs black and white, of course, too. So cool to see this similar changing pattern of lava at the surface at the summit, right? As they talked about in those old days, 100 years ago plus. All right, so moving on from the V1, what I will share now is that one photograph, and let me switch it here to our media of the week. This will be our media of the week this week, and this is a photograph that was released at the end of last week, but going back to August 24th here. And I'm going to scroll down here to the caption first and highlight some things. So they say the overview photograph of Hale Mountain eruption at the summit of Kilauea was captured by HVO geologists in the morning of August 24th, 2022, from a webcam site on the west rim of the crater. The active lava lake Silver can be seen near center right of the frame, with substantial amounts of volcanic gas emitting from the nearby west vent that's feeding eruptions. The lava flow that can constitute the remainder of the crater floor now stretch approximately 0.8 miles, 1.3 kilometers from the west side to the near side to the east far side. So that's something we've had come up before. How far is it? And there's the answer: 1.3 kilometers or 0.8 miles west to east. This is a long way, so it might be slightly shorter the other direction, but not that much, right? If you count to these little tips, it might be similar at 0.8, but maybe you get 0.7 in here or something like that. So that's about the width of it. And finally, one last sentence here to highlight. Two of the crater's downdrop blocks from the 2018 summit collapse are being overflowed at this time. One on the north side left and another on the west side lower right. USGS photo by Mike Zoller. So if we come into this photograph, the original, and we zoom it in, then here's that northwest side. You can see where there's still some cliff existing, and the lava is filling in this low-lying area slowly but surely. And since this cliff isn't even all the way across, you can see as we swing around here to the northern edge of it that when we have this kind of cat ear, like this first cat ear that we've been talking about for a while, but the cliff comes down to almost nothing, and the lava is actually starting to lap on in these areas like this. So scrolling it back down here as well, you can see similar effect. It's a little bit harder to see, but here, this is rock falls on the left side of this line and lava flows on the right side, and there's the onlapping contact zone right there. So what I found interesting is the mention of the second downdrop block. And so I'll scroll around and come all around the crater down here to this bottom right side, right? And this is that the westernmost block, collapse block. And you can see a big crack going through it right there. Right? But you can see also the edge of the lava texture is coming in and seems to be starting to lap onto that also. And this is one that we've been looking at from Kupinai, and looking at how the lava is coming up and up and up. It's that back cliff behind it from that point of view. And it seems like it's just about reaching the lowest points of that based on the caption shared here and this zoomed in view. So we'll have to get different angles of this coming up, and likely this is something that's occurring given the texture of this big pad of lava was likely all liquid at once. This is one of these big ooze-up flows, so we had a big ooze-up flow in this area, and when that happens, there's so much lava, you can imagine it might be flooding and starting to lap onto and overlap onto this westernmost downdrop block as well. So a cool little development to keep an eye on there. And our media of the week. So that said, we will switch into our lava viewing highlights report. And starting off with the park map, this is from National Park Service, Hawaii Volcanoes National Park. The entrance to the park is over here. And if you were to keep going past the visitor center, that takes you to the first overlook over at Uekahuna, where you can see ooze-ups on the east side. And I'm not sure whether this most recent one was visible from there, but it was large enough that possibly some of the parts of it were. The second overlook at Kupinai Pali is one we often focus on over here near the visitor center. And the last one, the one we'll focus on today, you got to go all the way around Kilauea Crater Park, either at Devastation Trail or Pua'i, and walk over to Kinakakoi Overlook. And that view from the east looks in like that, right? So that's the view we're going to highlight today. We have two pineapples. And we'll start off looking at the webcam, the B1 webcam, which is on this downdrop block, somewhere in the area over here, and it has a very similar view in that area. So that's a useful way to see what it looks like right now, or really a few hours ago here. And let's reload it and see what the gas has changed the appearance. So certainly there's more VOG in the area. That could impact some of the viewing. There it is. And moving on to the last week of B1. There is that ooze-up flow on that far right side. It looks a little different from the overlook because the viewing angle is steeper from higher up looking down, so you don't see from that angle much of this close part of the crater is hidden from sight. But you can see all this back part in here, and that's what we'll look at. Still pretty useful to see that. B1, and let's now switch to the two pineapples highlights. So here is a morning view with the main active lava lake over here, but you can see a big red lava flow to the right. That's that ooze-up flow visible on the right there. So we'll come back to that, but first we'll look at our main lava lake as the center of our investigation. And you saw we're zooming in here below Maunaloa. Maunaloa is in the background there. So there's that main lava lake, and lava moving in this from this angle, from this back right corner, and now it's sped up. Here is that central sink, and that's that southern sink, and the southeast sink that feeds to that southeast pit over here, off to this direction over here. And the central sink, that eastern sink over here, coming up as well. So you can see here, this is a regular speed video, now sped up. You can see how sometimes those sinks appear, disappear, come and go. So depending on when you're there, if you're there for just a short time, you might just capture a short snapshot of those conditions. But if you stay for a few hours, like Two Pineapples is streaming here, you really see the beautiful transition of what's spattering in one place and something starts off somewhere else and then shuts off. And meanwhile, they see the crust continues in this conveyor belt pathway over and over there. So, all right, here is the pre-dawn view of that. Let me pause it right here. So that's our main lava lake right there, and a glowing west vent just behind it. And then off to the right, there is that ooze-up flow visible, right? And so you'll see there's some vegetation that'll come up when we see the daytime views. But to give you an idea of how much lava is visible, right? That's how much is visible in a lake right there, and there's how much is visible through the ooze-up. So these ooze-up flows really are really dramatic and spectacular if you can catch one. Another reason to watch that tilt meter closely like those guys do. And so zooming in here, there's that ooze-up flow, the northern ooze-up flow, and after daybreak, some fantastic zoomed-in shots of that overturning process that Dane is referring to. So the lava comes out, it's forming a big crust as it cools against the air, and that crust is becoming thicker and colder, and meanwhile the lava underneath has got that trapped gas and trapped heat, and so eventually it bursts and cracks that crust, starts to escape out. That crust then is essentially heavy, so it's going to sink back into the lake and get replaced by that fresh lava, which will then eventually cool off. Once it stops bubbling, it'll cool off and form a new crust. You see that happening here a little bit with that gray area right there in the middle, right, where it's not bubbling as much. But really cool stuff. This is in real time. You can see all that bubbling and big plates turning over and lava rapids. It's hard to get a scale in this stuff, right, from this far away, but you wouldn't want to be standing anywhere near there for sure. So August 28th, that was just a few days ago. And sped up, here is the wider view of that overturning process, and once again sped up. I'm trying to show you guys a little bit more of that long-term big picture, right? So times 20, you see this is all one big sheet coming this direction. I've repeated it a few times here, but and you see these ooze-ups are happening at the perimeter as that flow is advancing and impacting this other area of flow that has liquid underneath it still. So there it is. Lots of good clips here. Mahalo once again to Pineapples for sharing your viewing experience with the rest of us here. Lots of good stuff here. So that's the viewing highlights this week. And as usual, if you're headed up there, check the National Park webpage for closures, for any notifications. They have the viewing webcams up there and the map, of course, what to bring, different kinds of views, and all of that. So certainly check the page before you head up there. All right, so that does it for the viewing this week, apart from the fact that we're going to talk a bit about the viewing hazards. Let's get this on the right page here. So here is the park viewing map, and we can transition to the hazard summary here because we're looking at gas as the main impactor of this eruption, right? The lava is all constrained within the crater. It's not affecting any infrastructure, communities, anything like that. It's in a perfect place to be. What I've been calling the lava viewing stadium. When it's coming up, you can see it from more and more areas, more and more perspectives and angles. Everything is in the green in all the public viewing areas here in National Park, and today the wind is blowing from the northwest, at least it was when I loaded this page, and I could try to reload it here and see if it adjusts. I'm still pointing from the northwest at 11 miles an hour here. So that means that depending on if the wind varies from this kind of northwest to like that kind of northwest, then it can start impacting the viewing area a little bit. So that's why you want to be aware of conditions. And if you're especially sensitive, then take precautions, of course, right? Whether that's bringing an inhaler or what have you, those kind of things. Check with the park for proper advice there, yeah. Okay, so here is the history by site, and really, mostly you see Kahuku coming up with SO2 and nowhere else, and this is a little strange just because if we come back to this former map, the Kahuku facilities are all the way over here, so it's if it's the wind is coming this direction, it's maybe not coming from the volcano right there. So interesting to note that, but otherwise everything's looking in the green, but certainly heed the conditions as you go. Overall, on the island, that little localized pattern is not showing up in a VOG forecast. Our VOG forecast from weather.hawaii.edu, the VOG mapping project, VMAP, is inputting an SO2 rate of about 1,400 tons per day and a current weather patterns and predicting the dispersal of VOG. And so you can see it's largely in a park area. It does swing into the Kahuku, South Hawaii area, right? South Point, Naalehu, Pahala areas, and does seem to wrap around into the South Kona areas as well. Also moving north where it can come into the saddle a little bit, but that seems to be the extent right now. And of course the impact of VOG depends on two things. One is the weather, but also it's the output rate. So the output rate at 1,400 tons per day is on the low end of what we've seen recently, and that helps minimize the effect a little bit. So there is still effects going on. We won't go into the all the site locations today, but it is an ongoing impact still happening beyond just visitors to the residents here of South and Southwest Hawaii as well. So here is what the SO2 might look like. This is a sand hill site near the summit where you actually have the SO2 spiking up at 4 or 5 ppm, depending on the day. This is the last month here at the top. But the USGS does integrated measurements of more than just one spot, and accounting for the wind and all of that as well. So here's our range of 2,400 tons per day to down here it's 1,200 tons per day. That's a typical range that we've seen of readings of SO2. And as you can see from these 2 points that happened a few weeks ago, it can turn on a dime. And often this is something we see with our deflation-inflation events. But looking at the deflation-inflation plot on our summit tilt here on the bottom over the last month, that has not been as much of the pattern. And interesting to note that we have this most recent measurement down here at 1,400 tons per day, similar to these other low values, despite still having this still rising tilt. Our tilt is showing an overall pattern that's still climbing up, right? The embedded variations have changed. We no longer have these short back-to-back deflation-inflation events like we were having quite a bit. Now it seems to be, we had one, but it seems to be more of this broader climb here over the last couple of weeks that corresponds to the beginning of the Ooze-up flows. That might correspond to a changing in the diffusion rates. We'll have to wait for more USGS data in future weeks to consider that possibility. But you can see a clear difference in pattern here from the right to the left of this ground tilt plot here. So curious to think about what might be happening with the SO2 there. And we've mentioned before, it could be a challenge of measuring it. It could be could be that it actually has gone down, right? It could be that it's getting mixed into the lava below that crust more so, and not escaping as easily. There's several possibilities to consider there. So we'll just leave it at that and wait for more info from the USGS. So our tilt, as I just said, has still been climbing, and the lava depth has been mirroring that. The 1 month lava depth plot, unfortunately, is blown out, and by that I mean that it actually was probably shooting the laser at some of that fog, and it caught what it thought were some data points all the way in here and here and here, which makes our scale end up being much bigger than it has to be. We really only need this scale to be from like 380 to 365 or so, right? But instead we have it all the way to 430 over the last month here. So all we can tell is that it's a slow, steady climb with little wiggles, and little wiggles, if you could zoom in on them, mirror this somewhat here, right? Largely so. So zooming into the last week where we don't have that blown out effect, well, actually we do. Come down here in 1 week's lava depth. There it is, similar plot, but there is a tilt, and within the last week, mostly rising, and then small variations here. Less than 1 microradian variations within the last few days here. So all of that falls in the range of normal, nothing surprising or really changed. It's just kind of looking for little clues of what might be happening, and hard to really tell in those details, but we keep an eye every week. So the whole eruption from almost a year ago, a year minus a month ago till now, it's been a climbing rate, and so let's see, we've had blown out values before, but that continuing slow climb is the story here, really. So we'll move on from that to the GPS, and looking at the GPS first at the summit at the top here, and I'm going to zoom it in. And we can see that our data has actually cleaned up quite a bit here, and this is largely likely to the processing of the data. So we'll have to actually interview a deformation scientist from USGS, but I'll tell you the little that I do know is that since GPS is satellite based, we do know that the satellites have predicted orbits that go around, and then after they actually fly over, they can adjust the predicted orbit to the actual flight path taken. Right, so that means that your satellite can be off in space from where you think it is slightly before you actually get that corrected orbit. And I suspect, just a suspicion here, that those very initial values sometimes, depending on how much error you have each week, and sometimes you may have none, and sometimes you have more, that can cause more of a spread of the data until you then go and you have, after maybe it's a week or so, you have that revised orbit file, and then you can actually adjust. If you use that data, then everything cleans up quite a bit here. So that's just one possibility of what's happening. But certainly we don't see that widespread that we were seeing before, right? So it seems to have tightened up, and more easily you can see this line coming up. You want to jump in here, Dane?
Yeah, I mean, we've mentioned many a time just that first like week roughly of new data as it comes in on the GPS. Each data point here, each dot that you see represents a single day. You get 1 pole a day. The issue with that is just what Phil was talking about, but we didn't exactly think of it that way. We were looking at it more like, hey, this GPS graph's showing one thing, and then you check a few days later, and it's like, oh, it's been corrected. Right, it looked like it was showing this, but now it doesn't show that really at all, or much less so. So really, we just got more patient with the GPS, and you feel like you want to use it because you only get 1 pull a day, and you're saying, oh, the first week you can't even really use that. Really, you got to wait. It's like, wait, so you only get 1 pull a day, and you're a week behind. Really, it's like, yeah, kind of, but that's you get the best bet kind of with the GPS doing that kind of hedging as opposed to aggressive reading of it.
Yeah, it's there's a lot of details. It gets complicated. We can go into it a lot more than I'm going to, right? Like all the tides move everything, or as we've been talking a little bit this week, Dane, right? Like it shows up on all tilt meters. They show the daily variations of tide, right? So like if you look at GPS that comes in and you measure it every hour, you can see those kind of things also. And so what point of the day are you actually measuring? Are you integrating it, averaging that out? And so variations can happen not just day to day, but week to week to week, month to month. On top of it all, and then you have a satellite on top of that, right? The satellite is something that when we're doing doing INSAR plotting, right? That's something that comes into play as well, right? When you're trying to get the most recent INSAR image and trying to use the most recent satellite pass, and you kind of have to use that noisier first pass data and then correct it later on. So similar kind of thing. And this is Kilauea. It's actually tightened up quite a bit. When we get to Maunaloa, we'll see Maunaloa is not as clean, at least not yet. So we'll just wait and see. But Kilauea today is looking pretty clean. What's that, Dane?
Looks if anything, Maunaloa looked like it got a little bit noisier over the past week.
Yeah,
but hey,
we'll get to that.
Work with what you got.
Yeah.
All right. Yep. We'll get to Q&A in a little bit on Kilauea. So if you got any last questions to get in, this is the time.
All right, so yeah, let's finish up Kilauea here, and then moving on from the summit, we can look at the Middle East rift zone, I should say, at Pu'u'o. 2 stations north and south of the rift zone by Pu'u'o, and they're showing contractions going down, which means the distance is getting shorter. And maybe it's curving a little, but it's doing so on a year-long scale, and it's really just pretty straight down with not a whole lot of change there. Even that data set's looking a little cleaner here too. So we do have clean local length on our label here. That's another indication that there's something happening to our data here. So that's the GPS today, and gonna use that to, well, really we're doing monitoring rather than hazards, so put the monitoring on there. But we're gonna switch here to looking at GPS and Volcano Watch. So I'm gonna stick in a Volcano Watch right here this week, and last week's Volcano Watch, which we couldn't get to because of website issues perhaps, is about the geodetic network. And that's the network that's measuring the changes of the ground shape, right? So there's a GPS, or nowadays often you see it, GNSS monitoring site deployed by HVO on the floor of Kilauea caldera, and this is part of that December 2020 response. And a lot of details in here, but I'll try to just pull out a couple of points that are interesting, right? They're really reviewing the status of the GPS network, and this article really is about the supplemental funds that USGS has got to upgrade the whole network and maintain it and all of that, right? So currently the network has over 70 GNSS stations and 15 tilt meters. They require routine maintenance and must be upgraded periodically and replaced if destroyed, such as in 2018. So the current upgrades, well, let's see. In 2018, lava flows destroyed 3 GNSS stations in the Lower East Rift Zone. Another 3 stations were destroyed in the caldera collapses at Kilauea Summit, so they were down 6. They did deploy new GNSS stations at nearby locations for continued monitoring during the 2018 crisis. These included antennas mounted on survey tripods, which is a setup typically used only for temporary deployments that last several days to weeks. Many of these rapidly deployed sites were decommissioned and removed after 2018. However, approximately 13 of them are still being used for critical monitoring and remain on temporary tripods. These sites will be upgraded and hardened using engineered fixed monuments and masts instead. New sites will also be installed to replace sites destroyed in 2018. So that's essentially it. They've also deployed 3 new semi-continuous GNSS stations in response to the most recent eruption that began December 2020. And also 2 more at the South Caldera intrusion in August 2021. And that's what's been done so far. New instruments are still being planned, as we've heard about in several of these articles over the last year. So since we're talking GPS, it's good to know that the GPS network is being maintained and upgraded and improved. Stations that were lost are being replaced. And that was a Volcano Watch from last week. There is one also this week. Let's see if I can get this page to load. But to start off with the image here. This is an image of a basaltic fissure eruption right there, putting out a flow. It's actually breaking up the side of this hill, and some of our viewers probably recognize this as not Hawaii, but actually Iceland. And that's the topic of Volcano Watch this week. Recent eruptions in Iceland sparked interest far and wide. And without going to all the detail of Iceland, right, they're essentially just summarizing the activity that's happened there over the last couple of years, right? So, and you can compare that to Kilauea a little bit. So, really, the current unrest in Iceland started in January 2020 with seismic activity and uplift beyond background levels. That led to increased seismicity in February 2021, and March 19th, 2021 is when eruption began near Fragra das Fjall. I'm not going to try it again. Forgive me, anyone speaking Icelandic. In the Miradalur Valley. So 200 meter, 600 foot long fissure, and it was essentially in the middle of nowhere, far from 6 miles from the nearest populated region and 1.5 miles from the closest road. That activity lasted 6 months, and after it ended, inflation suggested magma was flowing into the area at depth, and not unlike what we've been seeing here in Hawaii and after what happened following the December 2020 to May 2021 eruption. So you're just a little bit behind here on Iceland on that schedule. So in late December 2021, another intrusion earthquake swarm followed, which was similar to the one in March 2020. Then another break, 6-month break, and on July 30th, 2022, increased seismic activity reappeared on Reykjanes Peninsula. The formation suggested a magma from a shallow intrusion was approximately a half mile below ground surface, and August 3rd, a new eruption began. However, that second eruption in Iceland, unlike our second eruption in Hawaii, which is going on almost a year here now, it'll be a year at the end of this month, that eruption in Iceland began August 3rd and has already ended by the night of August 21st. Right? Tremor has ceased, no indication of activity, still being monitored, and time will tell if it's over or has just entered into a pause. And so that's the comparison of Iceland and Hawaii, I just mentioned there a little bit. Just at the very high level of just calendar dates and of themselves. So that's the Volcano Watch's articles from last week and from this week. And just to make sure we attribute our sources here, everything, of course, is coming from the USGS HVO. This is our most recent daily update for Kilauea. Still at Volcano Alert Level Watch, aviation color orange. Really minor changes. There's not a whole lot to highlight out of this update here, right? We still have the same measurements of rise of the crater floor of 450 feet, 137 meters since a year ago, and 104 million cubic meters or 27.5 billion gallons of lava effused in the last 11 months. Otherwise, SO2 mentioned, little tilt mentioned, and there's really nothing else. There's no more meat on this bone to mention right there. So that is really the end of the monitoring segment right there. So that said, we will transition to looking at earthquakes, starting on Kilauea as we often do. So recent earthquakes on Kilauea, here is the whole last year. And here at our right end, really nothing abnormal. We're still within that pattern of the what's normally the background in the last few months here. So everything is as expected. Zoomed into the last month, you see more of these variations day to day, but still pretty normal. You see one big jolt on this red line here, and that was that earthquake a couple weeks ago. We mentioned it last week. And on a map view, you can see, in contrast to last week, more of the earthquakes occurring now within the caldera area, and still some little ones on this Maunaloa side, right? But you see there's adjustments between Kilauea and Maunaloa must happen and pulses, so it seems like a little bit less over here and a little bit more over here today. Interesting little cluster here in the Southwest Rift, but nothing to be alarmed about. It's all just part of the same magmatic network. And the South Flank is still active, as you can tell by these low-level small earthquakes that are always ongoing in this area all the time. Bahala, still going off. We'll still await more results from there, but nothing abnormal going on there. And really nothing else to really talk about with earthquakes on Kilauea. We'll just go straight to the map here. So here is the last week of earthquakes on the map. Kilauea is this bunch right over here. Pahala is this bunch right over here. It's still active. The most recent earthquake is right there. Was just less than an hour ago. 2.1, 30 kilometers down, 20 miles down. Still ongoing in that area. We have a few of these offshore. Puako 1.9, 15 kilometers down. That's another just adjustment of the island, right? Similar at Mauna Kea. Adjustment earthquakes are normal around here. But the largest earthquake in the last week, if we zoom into Maunaloa here, 3.7 that occurred just yesterday on the northwest flank over here. And you'll see the depth noted, minus 3.4 kilometers. That's basically at the surface. So pretty large at the surface earthquake on this northwest flank of Mauna Loa. So we'll investigate this a little more. It hasn't really caused any major change is the long and short of it, but this gives us a chance to kind of step through our paces and look at the signals that we would be considering to tell whether anything is going on unusual there. Right, so just a little closer in on Mauna Loa, there is that summit crater of Mokua Ve'oveo, and our normal earthquake cloud northwest of the summit is usually over here, and it's a little bit further over there. And if you see it's on this black line here, that's that 1859 radial vent flow that went all the way to Waikoloa, right, off in that direction. If I zoom it out, you can see how far. That's one of the longest flows in Hawaii. I want to say maybe 30-ish miles, right, all the way to the coast over there at Waikoloa. 1859. So that's interesting, and let's look at that a little more. So that said, we'll transition from our earthquake tag to Maunaloa tag here and come into Maunaloa.
Do we want to tackle some Kilauea questions before we get into Maunaloa, or do we want to just group those all together in a little bit? Your call.
That's up to you. I was just gonna roll right in, but
okay. I mean, really, there's not that much really new on Maunaloa, so somewhat.
Well,
quick.
I have a lot more to say about Maunaloa still.
Okay, yeah. Well, then let's do some Kilauea questions. Knock them out real quick. Then we'll get to some Maunaloa ones in. Just while they're fresh. Dude asks about normal background noise. He has two questions, but does our standard normal background noise models work on actively erupting volcanoes, as in Kilauea's tilt increasing above pre-eruption levels? And you know it's higher than July 2018.
That's tricky, right? So the way I think of it is that you want to divide your volcanic activity into stages, right? So, and then within a certain stage of its kind of activity, it has that's why often I'll say normal background together, right? Because background changes from time to time. When you have no lava coming out of the ground anywhere, the background is different from when it's coming out of only one vent on a rift zone, which is different from what's coming out of the rift zone at the summit, which is different from what's coming out only at the summit. And so they're all different combinations of how it can go down, right? So background now, when I say background now, I mean what's happening during an eruption at the summit, that current background, like with Kilauea erupting and Maunaloa not erupting, and like what's that dynamic and what you actually see from the data as a background. So let me pull up for example, the earthquake plot here, right? And so in this case, because we're seeing on this plot 300 earthquakes per week coming up pretty normal, like that's what I would call the background, right? Now, if we were not erupting, if I go back to I don't think I have my 5-year plot on here, but then the background would be lower, but when lava was not coming out, was not building to eruption, and it might be less right after eruption actually begins. So the background can change over time. Is the easiest way for me to try to answer that. It's a good question, dude. If you're gonna go into it in more detail, then yeah, I guess it's gonna get really tricky. I don't think there's a one size fits all solution, really, if that's what you're asking for.
Right. And doesn't tilt get a little bit more tricky trying to extrapolate it from like past events to current? type of thing.
Yeah, so I mean, tilt,
itself, like it's
yeah,
just
tilt,
finicky little thing.
yeah. So there have been times when a volcanic system has been a certain sensitivity where you could say, okay, there is a certain tilt threshold. And when the tilt hits that threshold, then something's likely to happen, right? That's true. But if the system is changing between events, then that threshold can also change between events. So the next time a tilt reaches that same value, it may not trigger it because you've changed the system and you have a new threshold. So there may still be a threshold, but it may not be exactly the same level as it was back in July 2018, for example, right? And in particular, July 2018, right? Like we had that full collapse and lava coming back in. There's a whole bunch of details of gravity increasing. So we thought lava was filling in the cracks underground there, and then it actually coming up and popping up. And so it's changing the whole system and how loose everything is, how welded it is. And that changes how the whole thing vibrates. It changes how the whole thing swells. And like if you're pushing from below and you have one loose block and just move on its own without pushing on anything else, it's different from it being attached to the one next to it and the whole thing is forced upwards, and now you're having a larger range of effect, right? So the effect can kind of grow as well over time. And July 2018 was right in the midst of it, so that's a really tricky time to, right? So I would consider, if I was going to break it into phases, you really have to go post, August at the very least, 2018, right? And you have between May and August is the actual collapse time, and you have previous to that 2008 to 18 on the summit when Lava Lake was open, and previous to that, you have 2008 back to 1983 when it was only the East Rift Zone, and et cetera, et cetera. I mean, right. That's how I would how I would put it. So yeah, thanks for that question,
right.
dude.
Our old friend Travis Sanders has a more kind of fun question, or maybe not so fun. It says, so is it safe to now climb into Pu'uo'o?
That's a good question. I don't know that I can answer that, apart from to say that I think the park still considers it illegal to climb in there, so that's probably the most relevant thing.
They're not going to allow it. Let's get that out of the way. But like my thing about it is like I know I've played around enough cinder cones to like know that I'm not going to trust the handholds and the footholds, stuff like that. So that immediately means you're going to be on a rope and you're going to be just rappelling in and then using like an ascender type of thing, climbing the rope out. Even then, I'm like, yeah, your rock fall chance is incredibly high, I would think, and probably makes it way too dangerous to even attempt.
It's deep.
Just my thoughts on.
Yeah, I mean, it's deep. Yeah,
Fragile.
Okay, so my take on this, Travis. I think it's less safe. Like I like if the crater is all the way full of lava, then there's less height of wall to fall in, right? It's just like everything's held up by the lava, just filling that whole column in there, right? And so since it's all withdrawn, everything is less stable than before, right? Because I mean, it used to be before you'd see, I'd go, when I was a volunteer with the USGS, we'd go there, I don't say frequently, but we'd look forward to going there, and you land and you have to walk over these giant cracks on the side of the cinder cone, and you're like, oh, it doesn't look safe. And the geologist explained to you, oh, that was from the initial fountaining event when it occurred back in the 80s, and everything is essentially welded together now, and the crater is all the way full, and it's basically buttressed, and everything's fine. But now, I don't know if that's all true anymore, right? It's because that central support is gone. I don't know that I'd go very
I wouldn't
the
trust
edge.
it. I wouldn't trust it at all.
Felt safer before when I've walked in there following USGS scientists before, but yeah, I mean, you just walk right up the flow, right in. Not having to worry about ropes or rappelling or anything like that. Like, I don't know if I would do that.
I mean, Travis points out that the lava would make for a softer landing.
That's what I mean. If you actually have some liquid in there, it'd be better. I agree, Travis, right? No liquid in there is not as good, so that's what we are now. There's nothing in there right now. So,
all right. Here's a question that's more serious and a little bit easier to answer. For how long? Lisa asks, how long do you think it will take to get to the next down drop area? So
So tricky.
of the eruption.
Yeah, it depends on the rate still, and the rate's changing up and down. And so I'm still sticking to my average rate that I pulled out a few months ago, and that puts it by about Thanksgiving, in that next down drop block, like above most of it. I just pointed out today on that one image how the cliff is kind of peters down in one side, right? So it's starting to go onto that block already, really. Just moving up the ramp. And it's going to turn up the ramp and go a different direction. And on that eastern side, it's similarly starting to go up the ramp. And that one might be sooner. But it all depends on the ooze-up flows and where they're coming out. And yeah, there was always a lot of error in that estimate of by Thanksgiving. And, the estimates ranged from October to December, really, right? It's September now. So maybe as soon as next month. That would be the window, right? But I'd say more certainly by Thanksgiving. It's still what I'm holding to. Yeah, so thanks for the question, Lisa. There are several down drop block areas, right? So like it's on a couple now, but the next one that maybe is noteworthy, I'd say. Yeah.
Not sure how to pronounce this, but Dicey member asked, when was the last time? Oh yeah. You got that one. I don't.
So when was last time the crater? Yeah, it looks. I don't know. It looks like a Spanish, or I don't know if it's Spanish or an Italian. It looks like a Latin spell in there. But anyways, when was the last time Kilauea crater emptied and filled prior to 2018? To that scale? Oh gosh, maybe 1868. To that scale, right? Maybe in the 1870s. It might have been in 1870.
Because there's periods where there's no lava in there, but visible at the surface, but to actually collapse the crater type of thing, you got to go back.
Yeah. So 19th century is the answer, basically, right? There were other times where you'd have craters formed. The last time we had a crater form at Hale Mountain was 1924, but that was an explosion, right? An explosion that followed a withdrawal of magma and the floor of the crater falling out. That kind of thing happens pretty often, but large-scale collapse, similar to 2018, it goes back to the 19th century.
All right. Last question on Kilauea. Dude asks, Iceland or Spain or New Zealand?
Oh, it looks like I'm getting Dane to hiccup here a little bit.
Basically, when we ask for it.
I think you froze on my end. I'm not sure if it came through or not. But so the question is, once again, why HVO doesn't share the same data as Iceland, Spain, or New Zealand, RSM, SM, and INSAR? The short answer is I don't know. That data is all calculated, right? The INSAR in particular is maybe easier to answer because the INSAR has a lot of issues in Hawaii, and it's hard to release automatic ones and make meaningful interpretations of them, and especially to expect lay people to make those interpretations. So those issues are atmospheric interference, the moisture, a lot of moisture here all the time, the vegetation, a lot of vegetation on the whole east side of the island. Those are the biggest challenges there, right? And then the elevation, right? You have a large range of elevations in a small area that can also affect your INSAR capture, right? So that's the INSAR answer. RSAM, I don't know why they don't put that out. I know that plot exists because I programmed it within the USGS 25 years ago now, maybe. So I know they have it.
Yeah, it would be nice to have that. Yeah.
Yeah. So it's really we're very thankful that the USGS has all this data online. They're really one of the first observatories to put all this data online way back when, as I'm saying. They've added some stuff to it, but a lot of the old stuff hasn't really changed, and it's just going to stay the same, right? So it's nice to have occasional INSAR. It's nice to have new stations here and there, but a lot of the stuff hasn't really changed in a long time, right? So I don't know the answer.
It would be maybe. I mean, the best thing you might be able to do is just write to ask HVO at USGS.gov and just request that they put it on there publicly. I mean, maybe if they get enough requests, they'd start considering doing that. But until people, somebody like dude that starts messaging them and requesting it, maybe they just don't know that it'd be that easy just to share, or maybe they could start working towards it.
Yeah, that
Just
brings
a
up
thought.
another issue, right? With the whole, what we saw happen last week during our update, the whole website has infrastructure falls within a whole larger USGS tree, right? So they have a huge, I don't know, they
Right.
may have limited resources, we'll put it that way, and they may have challenges with how much data they can put online with the current design of their website, right? It offers some challenges, I think. But
Yeah.
I wouldn't say that that's a hard barrier. That's something that can be
Deal
overcome.
breaker.
Yeah.
Yeah. All right. Well, that'll do it for questions on Kilauea. We will be taking questions on Maunaloa and maybe Samoa as well. And yeah, we'll get into that Maunaloa update that you were just getting started.
All right. So back to Maunaloa here. Let's get my label back on here correctly. And switch slide. And we'll just go into this week's Maunaloa update from the USGS. Still at alert level advisory, aviation color code yellow. Not erupting. No significant changes on the data streams. Otherwise, the only change is, the only real abnormality, according to the report, is seismicity slightly above long-term background levels. Right, there's that background levels once again. So observations in the last week: 108 small magnitude earthquakes. That's in that same ballpark as we've seen. It's the normal range. We've seen some weeks that it was quite a bit lower on the low end, but this is kind of the normal. The majority less than 9 miles below sea level. Largest 3.7 below the northwest flank. That was felt by 20 island residents. So this is acknowledgement of that 3.7 that occurred. Is on there and was reported felt, but really nothing else was noteworthy about it for them to put it in here. So we'll dig into it a little bit more. GPS measurements show low rates of deformation in the summit region continuing through the past week, and everything else stable. Right? There's really nothing else to analyze and summarize there. So let's come in here. This is the USGS Maunaloa page. Let's hope it loads. All right, so I'm going to go into the settings up here and turn earthquake data on. There it is. And there's all kinds of other symbols on here, which are the instrumentation. So there is our 3.7 earthquake right there. And the closest site in GPS is this one, ALEP. I click on that, and unfortunately we don't have any live graphs for that. One over here to the side. TOUO, click on that one, and unfortunately nothing there on the side. The next closest one over here is STEP. Nothing. So unfortunately, it's hard to get very close information, right? So let's see, we go all the way over here to the side, and if I were to click on one of these, and no real obvious changes happening in the last 24 hours, which is when this earthquake occurred. So everything's all normal there, and really, it's just you'd likely only see a localized effect anyway, so this is getting pretty far, right? So there also is a triangle underneath this little star, which is a seismic station, but hard to click on it from here, the way that this map is set up, unless I go and filter it out. So what I've done is gone and done that already, but before I get to that, let me just review this location of it, right? Come back up here, and let's change. Well, let's just go back to, I don't know, let's see, how do I change this here? Settings, and oh yeah, here we go, map layer, let's do world imagery. Come back down. All right, so there we can see where that earthquake sits on that lava flow, 1859 flow. in comparison to our cloud of earthquakes here in the northwest of the summit and the summit itself right in here. Right? So a little bit further on, and this is the side of that flow. It actually had several vents. One was all the way up here. You can see one over here. Looks like there's another one in here somewhere. And so these are the radial vents that can erupt Maunaloa, normally in its north and west quadrant. And this is one of the few examples that's within historical times. So here is a little clip from the Maunaloa presentation, right, about this flow. So the 1858 Maunaloa eruption began with a brief summit eruption, followed by a radial vent eruption northwest of the summit. It generated one of the longest lava flows in the state, 52 kilometers, 32 miles long, shown in orange on a map. Lava reached the ocean at Kīlauea Bay in 8 days. The eruption lasted 300 days. Lava flows from radio vent eruptions on Maunaloa pose a serious potential risk to develop areas in the north, west, and northwest flanks of the volcano. This is because radio vents can potentially form nearly anywhere on those flanks of the volcano. The response time for Maunaloa radio vent eruption could be very brief. So just because of this location of where that earthquake happens to sit on this radio vent, and the fact that radio vents are a unique thing of themselves, and in anticipation of any of these questions of are these things related, we're dive into a little more here. So here is the last 24-hour seismic plot, and this is the earthquake in question right here. And when you see this box-like appearance, it means it's maxed out the recorder, right? So it's what's called clipped. And they've been clipped on the edges. You don't see the full scale of the shaking, which should probably be something like that. It just kind of gets truncated there and there. And once enough of that initial motion goes by, then you can see the detail coming a little clearer. Right, so that's, you can see other earthquakes have the same kind of clipping, and one real quick and dirty way to tell how big an earthquake is to like look at how long this period of clipping actually occurs, right? So each place in the world has its own kind of back of the napkin calculation. You can say, oh, it's going to be this many seconds, it's probably this magnitude, and this is something HBO has done for a long time, and then they refine it with all the algorithms. But if when you used to actually go by and look at the paper, when you physically look at the needle moving, that's what you do, is you'd look at the length of clipping time here. So that's it. That's the event. It's a big one, but it's not ridiculously big where it's really clipping for an abnormal time. So, and you can see it's followed by a bunch of other earthquakes in the area, and some beforehand, but not as many. Looking over 24 hours, here's what that plot looks like. There is that 3.7. You can see a lot more of that quiet beforehand. You see some other signals coming in here, like this kind of thing is likely a helicopter flying by. That's an area that gets a lot of air traffic near there. And you can see that really after these initial couple bigger possible, it's hard to call them aftershocks, so they may not be in the same location, right? But these other following earthquakes here, that the big earthquakes seem to quiet down on this plot. So there's no tremor coming in, there's nothing unusual going on there, it's just a near surface adjustment of the earthquake, of the ground. Now, there are other ways to get at GPS, and not as good. We could do better with more time and download all the data through here, but we're just going to go to the Nevada Geodetic Laboratory and pull up their automatic plots, which are much longer scale. Here is our time series plot. What I want is the plate fixed. So I don't want to example. If I'm looking at this, all I'm seeing is everything, all of Hawaii is going northwest. That's not really helpful. I want to tell what's moving between locations on the island itself, right? So now I want to go to the plate fixed and look at this station, and it's tricky because our scale on the bottom, you can see here, goes from 2022 all the way back to 2004 or so. And so this is almost a 20-year plot. And our most recent data is this purple stuff way down here. So you can see that it is in this component, which is the east component, and it's going to the west pretty fast there, but it's not like it happened just when an earthquake occurred. It's been going on for several weeks already. So likely this is related to that storm we saw about a month ago. That's when it's accelerated on this north component. You see it's similar, it's climbing, right? But since we have 20 years of data, we can also scroll back and look back at this era of 2004 to 2005, which was an era of intrusion on Maunaloa. And you can see possibly faster, possibly similar movement at those rates there that are occurring now. But once again, this plot's so, our data is so squished into a few points because we're looking at 20 years. So it's hard to really tell any detail on that. But it does give you a little bit of the overall long-term pattern. Right, on the up here, you can zoom in on some of these pinks. You can see there is some spread there, but once again, hard to really tell. And the average values aren't really, which is what the red line is indicating here. It's like the modeled fit. No major jumps occurring recently here. So if we saw this thing maybe shoot straight up, right? Like this point is not here, but it's the plots all scaled off, and you can tell something really major is going on near the surface. And we're not seeing anything like that. It's fitting within certain trends. It's showing fast rates of adjustment, but that's not a surprise since we're seeing a 3.7 magnitude earthquake at the surface right there. So that's the best we can do for the GPS. It shows you guys the seismic plot already. And so really the long and short of it is what this is telling us is how broad this zone of impact is and of swelling, and maybe coming back to this INSAR image released by the USGS a few weeks ago, last month. We can see, it's hard to tell exactly, right? There's a lot of, like I said, constraints on this, but one thing you could possibly look at is where does this pink band start, right? And so it gives you an idea of because these lines are stacking closer together here, right? So it's a little bit of a change. It seems like there's a zone that's a little bit different, and it's about maybe that big, something like that. So, and our earthquake fits into that zone over there, so maybe that's related. It's hard to tell. I'm not an expert INSAR interferogram reader, and we don't have the details of the look angle or anything like that on here, so it makes it extra hard. But this does suggest a broad area of adjustment and inflation as well, right? So that's kind of the long and short of it. The take-home message here is that it's adjusting in the long term. It's still swelling. Nothing looks like it's failing, apart from an individual rock here and there that might cause these earthquakes, like the one we just saw yesterday. So that said, let's go back through our regular Maunaloa paces and look at Maunaloa earthquake rates. That said, so here is the last month, and 1 month ago was our earthquake swarm, and really for this month, background has been this 20 earthquakes per day or less, right? Just a reminder though, this plot is only capturing and counting the earthquakes that fall within this map. See if I can get it a little smaller for you guys here so you can see. Yeah, so within this map, right? So there's the last week, and that earthquake would be off the top just a little bit right over there. Right? Looking at the last year plot of earthquakes. So you can see that for the last 2 weeks, we've had high values, over 100 earthquakes per week, right? And depending on how you consider your background to be, right? If you consider background to be, that's the whole year, we've had times like this before, then it's more normal. If you consider background to be what we saw during this interval right in here, at 50 earthquakes per week, then we're above the background, right? This is kind of how the background can be this flexible definition since we're talking about it here. And if we're to look at the 5-year plot, right, then you can go back to before 2018 and background being a whole different thing once again. Earthquakes per month on a plot now, but you can see this was 100 earthquakes per month. That after 2019, 400 per month was more or more, maybe call it 300 per month. And we're at that level that's been varied upon since early 2019. Right? A little bit on a higher end, as you can tell, right? But certainly that occurred before too, and certainly time is much higher than what we have right now. So the last month on Maunaloa, that earthquake swarm, about a month ago, you can see where it actually was, mostly in this upper summit region, just as a reminder. And a little bit afterwards and before in this little cloud in the northwest, which is always there. Okay. So, where's my Come on. All right, so the ones in the caldera, those are the ones right directly above this zone of magma inflation. And the ones off to the northwest, that's the site over here as the magma reservoir is pushing to the northwest, and the northwest flank doesn't move very much, so it builds up and it causes that pressure to cause earthquakes there. So we're seeing another earthquake that's occurring further over, and it's more something like this up over here, right? So just pushing on this, just pushing on that, and this whole area pushes on itself. Whereas the southeast flank can actually move away towards Kilauea and actually physically displace more easily. So that earthquake's in Maunaloa. Monitoring data on Maunaloa. Let's get this the right size and review. There's our tilt meter is a red triangle, and our distance cross caldera north to south is what we're measuring here. So first a tilt meter. For the last week, you just see these tidal daily variations. For the last month, the tilt excursion that was documented, just scrolling off the left over here, it does appear like there was a little more adjustment occurring right in here, perhaps, right? If you take this average, maybe it goes like this. Something like that. So it seems like there was some second event that occurred somewhere in here that we didn't necessarily see, nothing major, right? But the swarm had already ended by that point in time. But interesting to note that. When you look at a GPS here, this is the last year and the last 5 years. So let's zoom in on this once again. Right, and so this is what we're talking about before as far as this being pretty noisy data. And whether it's clean and corrected or not. So if I scroll back over here, this does say clean, but it could be that there are other things affecting it, right? The other sources of noise are not able to be corrected. So this is tricky, right? So we did see, Dude, your comment last week about the drawing the lines on here, and this is super subjective, really, right? So I mean, it's really we try to be careful because we know that the plots can change, and because we see this variability, like when you see a scatter like this, for example, up in here, right in there, you can go back to previous times, like in here, where you see quite a bit more scatter as well, but the overall trend doesn't seem to change, right? And it seems like there were times when we actually saw better clustering area, times like this in here, right, where it seems like everything's moving all together. And then maybe one way I think of it is maybe you're having more individual blocks moving in between themselves, which causes more of this noise. Times when you have more of the scatter right in here. So it's really hard to draw a straight line through all of this. You know, one way to approach it perhaps would be to draw envelopes. So for example, you could say, okay, well, you know, there's like something like this could be an envelope. Well, that's kind of, I'm not really liking this. Let's try down here, right? So maybe you have an envelope like that, and then on the bottom, you go like this. It's hard to catch every single data point. You know, you're gonna have some variations, right? But maybe it goes like that, something like that, right? And then maybe here it's going more like that. Well, maybe I can even go all the way. Maybe it's going something like that, and here pull it a little further and up like this. So it's, you know, that's broadly how confident I would get with these kind of changes, right? I look at more at the range of it and the whole bracket of it rather than individual data points. So that said, coming up to the top right here, you know, I might go similarly, I mean, somewhere in there and somewhere in there. Maybe it's tightening a little bit, right, if I'm drawing it this way, but certainly it's rising more than it was before August, we can say for sure, right? Whether that's happening here in its very farther right end, it could be. You could draw this different. You could draw it, you could draw this like steeper like that. Or you could draw this steeper like this. Let's see if I can clear this off and clean it up a little bit here. But another way to draw it, perhaps, you could, you know, maybe go this steeper here. And you can go flat, and you can go steep again. You can see how you can interpret this different ways. I'm not as comfortable with this one as I am with the one we showed previously, where it's the more broad envelope, something like this. Right.
So does that envelope principle also apply to the vertical components?
Yeah, that's. I also do that with the vertical, so I can scroll down here to the vertical down below, and it's a much larger scatter there, right? So I mean, I really would like to catch much more of the bulk of the points. I mean, I always like to kind of scroll back and see and go, look how noisy it is back here in 2021. Like, you really, right? I can draw trends through here as well, obviously. Right? But I'm missing quite a bit of the data on the outside of there. Right? So likewise in here, I would say more easily you can draw this envelope over here, right, where you can see, okay, well, from April 2022 to August 2022, it seems to be doing mostly the same thing. And then it's changed. And then how do you do it from there, right? So hard to say. You could draw it like that. Maybe one way to draw it. Right? You could draw it more like that, maybe. Let's turn this back on. Like a more conservative approach, maybe something like this. And then over. Right, so undeniably it's coming up in a long-term trend. It's just really hard to tell the details of a small scale within the last week, within the last 2 weeks, within the last 3 weeks, because of all the scatter in particular there, right? So that's a little bit of the art of it. Share with you guys there, and when I draw my lines on the map, that's why you could easily have a different interpretation than mine. And mine is just based on my experience of looking at this over time, and then thinking something was going to happen because I was convinced it was going up really steep, and then nothing actually happens, and the data gets corrected, and then
right.
It's been 25 years of doing this, so
the main thing is just being consistent with your application, right? However you do draw the lines, as long as you just draw them consistently, using the same methods or whatever you're doing, then that's good to go in my mind. It's just that consistency. When you start being like, oh, I'm going to change up the style, then it's like, oh, okay, well then, kind of gets weird.
Yeah,
that's just my take on it.
Yeah, so you could do some filtering or cleansing functions or stuff like that. You can do that kind of stuff as well. But that's not what's being presented to us, and we don't have enough time to go and pull out all the raw data and crunch it like that, right? At least not currently. Maybe someday we have an intern to do that.
Right.
Cross our fingers.
All right.
So that is the GPS on Maunaloa. There's 5-year plots on here also. I've kind of skimmed over them, but that kind of shows you how our pattern fits, for example, now over here at this end compared to what we've seen on 2021, where we had much larger swings happening for longer, right, in an overall long-term pattern here, right? And remember, in the last 5 years, nothing's erupted in Maunaloa, so all this has happened with that eruption here. And likewise on the vertical here too. So webcam on Maunaloa summit. We're not at the summit, but here is from Mauna Kea, looking from Mauna Kea south across the saddle to Maunaloa, and that earthquake is in this area up in here. That's where that radio vent source area comes, and that flow kind of went off in that direction. So the clouds coming and filling the saddle here. You can see a antenna here in the foreground, but let me see if I can get this to play the last 24 hours. Something wrong, Dane?
You're lagging pretty badly right now. Just seeing how badly it is.
Maybe I'll give it a second, just in case here.
Yeah. It might just be a little bad patch. It looks like you're back. All right, I'll let you continue.
All right, so yeah, it seemed like my page was loading similarly slow to me here. So here are the last 24 hours from Mauna Kea looking south at Maunaloa. When it loads here. There it is. Nighttime last night. Oh, it's stuck. Come on, get to sunrise this morning and show me the clouds flying by. Here it comes. Sunrise, and here come the clouds. So from Mauna Kea looking south at Maunaloa, and then getting obscured here by the clouds more recently today. So all still quiet on the surface here today. So I thought I would do one last thing here, which is summarize not Mauna Loa, but I don't actually have a title for this, but the USGS is covering all kinds of ground these days, right? We talked about them, the Kilauea update, we've talked about Mauna Loa now, we're going to talk about Samoa here shortly, but also thought I would cover the monthly update of the other volcanoes on Hawaii. So Hualalai, no significant activity, 11 small earthquakes below magnitude 3 on par with previous months. Haleakala, no activity, no earthquakes on a volcano in the past month. Mauna Kea, no significant activity in the past month. 45 small earthquakes, mostly below magnitude 3, on par with previous months. The largest one was a 3.0, August 23rd. Kamaehua Kanaloa, formerly known as Loihi, no significant activity on Loihi. 54 small magnitude earthquakes in the last month, below 3.0. And there you have it, right? So they're covering all this area, and then they're also covering Samoa. That is what we have for Mauna Loa. Do we have anything else in Mauna Loa, Dana, or should I switch into Samoa here coming up next?
No, you got no questions on Mauna Loa right now. I think you're good to go to proceed. If I did miss a question, go ahead and drop it back in chat, and we'll get it at the end.
All right, okay. So we'll switch over to our Samoa summary here today. And let's go over here first to our orientation map. Just to remind you guys, this is American Samoa, which is southwest of Hawaii towards New Zealand. And in American Samoa, there is Tutuila Island, where the capital Pago Pago, and then off to the east, the Manua Islands, and then the seamount where the hotspot is. We're zoomed in on Manua Islands, which are really Ofu and Olosega Islands that are nearly joined by a bridge here, and then Ta'u Island, which is a center of activity at present. Okay, so that's our orientation. And on Ta'u Island, Fitu'uta village over here on the northeast. Let's zoom this in a little more. Fitu'uta on the northeast, and then on the northwest, Faleasau. And notably, there's a old tuff cone right here you can see is breached in the ocean, and a harbor and a town sits within that tuff cone. We'll come back to that here in a little while. So the earthquake monitor is still running. Let's see if it'll load for me here. It looks like many of my preloads are no longer preloaded. So we'll give it a second to come up. And seismic data. So there's still some earthquakes on here. These spikes, something like this, right? But it seems like there's not as many at the present. You do see some more of this kind of tremor coming in some areas, but hard to tell really from this instrument if there's anything significant. So we will rely on USGS notices, and yep, all my everything did reset. So okay, I'll just click through it all and show you guys. Let's go to the Hawaiian Volcano Observatory. Let's go to Ofu Olosega volcanoes, and let's look at the two notices in the past week. So Ofu Olosega on, where's the date here? So it was Friday last week. I want to say it was the 29th. Ofu Olosega back down to color code green for aviation from yellow. And if we scroll down, back to volcano alert level normal from advisory, right? So what essentially happened was prior to last week, before we had the USGS install the more advanced seismometers, it was not exactly clear where these earthquakes were occurring, right? However, by the end of last week, Ofu Olosega Islands volcano has been ruled out as a source of the ongoing Manua Islands earthquake swarm. Data from seismometers installed on the Manua Islands this week confirms that ongoing earthquake activity is related to Ta'u volcano and not Ofu Olosega. Accordingly, USGS is lowering all the stuff for Ofu Olosega. Ta'u Island remains at advisory yellow. Due to the closeness of Ofu'olosega Islands to Ta'u Island, residents of Ofu'olosega could still be significantly affected by events that may take place on or around Ta'u Island, right? Especially if you have any kind of tsunami or gas emissions or particulates, that kind of thing. So, yeah, as I say, possible hazards: strong damaging earthquakes, local tsunamis or large waves related to underwater activity, or landslides and or ash or gas from eruptions. So that is just the Ofu'olosega to kind of close a book on that, and we really focus on Ta'u itself from that point on. And let's see if the most recent Ta'u Island, yep, there it is, update comes up, and let's go to this version of it here. So as of today, the swarm continues with no significant changes in the past 24 hours. Preliminary data analysis suggests a wide area of possible earthquake locations extending from deep beneath Ta'u Islands to shallower depths around 6 miles to the north. The source of the earthquakes has not moved within the Earth since monitoring began 3 weeks ago. The source position has remained constant. Seismologists continue to examine the data and refine locations. In the past 24 hours, the network has detected 27 earthquakes large enough to be felt by people on Maunaloa Islands. Largest event 3.2 at 3:49 a.m. SST. I'm guessing that's Samoan Standard Time this morning. Many small earthquakes undetectable by humans also continue. Okay, so it's unclear if eruption will continue, or if this unrest will escalate to eruption and exactly where it might occur. All this text is really not new. There has been some new updates over the past week. But to recap those, I've kind of put them together here for you guys, and I'll kind of start from the end of last week. And starting on Saturday here, which is when they were able to start installing seismometers, right? So on Saturday, data from seismometers installed this week allowed seismologists, earthquake scientists, this is really a hint that they're acknowledging a new audience in Samoa that maybe has never seen their volcano updates before or is not familiar with their terminology, all that kind of stuff, right? So here's earthquake scientists, seismologists, estimate the number of earthquakes that people in Maunaloa Island might feel. In the past 24 hours, people may have felt approximately 34 earthquakes. The largest of those was 2.8, coinciding with resident reports. Including earthquakes that people would not feel, about 25 earthquakes per hour have occurred in the past day. So this kind of goes to show, looking at the reports, right? There are similar number of earthquakes per hour. We heard 20 to 30, that range, right? But not all of those are felt, and we're having in the felt range about 30 per day, right? So this is how they're reporting it now. Is there's some threshold? They're not saying what the threshold actually is, but you would guess that it's obviously below 2.8, right? Maybe a 2.5 or something like that. And there's 34 of those. And moving to Sunday, there were 31 of those. Many more undetected and are no longer reporting how many per hour going on here. But on Sunday, we have this text as well. Residents of the Maunaloa Islands have been reporting booming noises for many weeks. And recent data analysis confirms that these sounds are related to earthquakes and not to other sources. The booming noises have been picked up on sensors that measure very low frequency sound waves on the island of Ta'u. They also correlate with earthquakes recorded on nearby seismometers. These sound wave frequencies are at and below the lowest range of human hearing, like those that whales use to communicate over long distances. Geologists flew over the island of Ta'u yesterday and saw no signs of recent landslides, rockfall, ground cracking, or other activity that could have caused these sounds. Booming sounds are not uncommon with earthquakes and could occur as earthquake vibrations interact with the atmosphere. So a little follow-up on the booming noises there. Still not quite clear, nothing obvious on the surface, but they are correlating the energy release to the earthquakes. So that's interesting for sure. And as far as volcano monitoring, this section's been updated as of Sunday. Volcanoes on the Maunaloa Islands are monitored with a limited real-time seismic network consisting of 3 sophisticated seismometers, 2 on Ta'u Island and 1 on Ofu Island, and 6 microseismometers on Tutuila, Ta'u, and Ofu'olosega Islands. Satellite remote sensing is another tool being used which may detect heat, volcanic gas, and volcanic ash associated with early phases of volcanic activity. So most of the days, you're seeing nothing seen on a satellite, nothing seen on a satellite, right? So I'm just going to pick out the things that are different day to day here and not keep repeating that.
Phil, I got a question for you here.
Okay.
Considering this was an eruption that was in that the center of that caldera, which is very deep out there, right? That collapsed caldera out in the water. And they only have sorry. Like just talking about like an eruption, if it were to erupt out underwater somewhere, with that equipment, how would they know it's erupting? Because you're not going to be getting like thermal scans really, because it's too deep, right? You're not going to get SO2 with that. It's going to get absorbed mostly. Like it'd just be like, what's the signature you're looking for there? You only got limited equipment, so right? You don't have any eye down there.
Yeah, I mean, so if it happens in a deep sea, then yeah, you may not see any SO2, and you may not see anything actually shoving to the surface. You might just see like a big raft of pumice, and that's something that you see sometimes, big pumice rafts appearing on a surface, and that happened in 2018, right? But that's not what the history of this area suggests. If we remember our account last week, they reported the ash was shooting through the water 2,000 feet in the air. Right now, if it's penetrating the surface of the ocean 2,000 feet, then you're definitely going to get gas emissions. You're definitely going to have ash visible on satellites, for sure. Right. But more directly, the seismometers allow you to measure the ground tremor, right? So if you can kind of calculate where the earthquakes are coming, where they're coming to the surface, that would give you a likely point where it might erupt, right? It's not guaranteed to erupt even then, but like if you were gonna suggest a place where that might happen, most likely that would be where the earthquakes are closest to the surface. And if you switch from having those earthquakes to having constant vibration, then you might extrapolate that those shallowest earthquakes have breached to the surface and that there was an eruption occurring. Even if it was underwater, you can still pick up the harmonic vibration of the ground and lava coming through the vent even underwater. Right. Yeah, but I do suspect
so that might be the earliest way you'd be able to detect it is with the seismometers that they have deployed out there now.
Yeah, I mean, honestly, I think you're going to have earthquakes ramping up more so than they are now, right? If it's going to lead to an eruption, you're going to see an increase in earthquakes and earthquake rates and earthquake counts, and maybe not so much in the size, but certainly in the counts and frequency. Which will lead people to be on alert more so, and someone may actually see the thing, right? Like, the way they first saw it back in, what was it, 1868, I want to say? I forget the year now, but was they saw the water churning, and they're like, at first they're like, it's a big school of fish. And so they went out there, and like the next day it was like, no, it's in the same place, and now there's rock shooting out of the ground. No, it's not fish. But,
Turning water would be a good hint too.
Are bonded with the ocean pretty well. Like probably notice if something's funny going on at the ocean, whether it's like agitation of the water, whether it's discoloration, whether it's bits of pumice floating up or whatever else. Yeah, I mean, if the place where the lava is going to come up has something there already, and you displace that and you push that out of the way, then that thing, whatever that is, could pop up, right? If maybe some bits of coral or something, I don't know. I mean. But it would be something weird like that, right? And because of how shallow that area is, and in particular that report from the 19th century, I would expect someone would see it shoot out of the water. Yeah.
If it breaches the surface, then it's a much easier ball game.
Yeah. But you'd know to look for that ahead of time, because there'd be more earthquakes ahead of time as well. Yeah. Mm-hmm.
All right. Well, I think that gets that. Is just throw it in there.
Yeah. So okay. Yeah. I mean, and one issue is just to mention, the drawback of satellites is that the satellite's got to fly over there, and the satellite's not parked over Ta'u all the time, right? I mean, it has to fly over and take the scan. Right? So I mean, I guess there are some that are the weather satellites are catching all ash into the atmosphere kind of thing, but some of the other ones that might measure ground information, for example, might be more intermittent, we'll say, right? still important to use satellites and visual, and there's a whole bunch of USGS there also. And what I'll say here as well, from the Monday update, they repeat the location hasn't shifted. They repeat at least 30 earthquakes large felt impact by people, many more undetectable by humans. But here is a key added sentence: in the coming weeks, USGS staff will install GPS receivers to improve Maunaloa Island's monitoring network. So they go on to explain that it detects slight movements of the ground and it will help better understand what's going on the ground. But if you have GPS stations also, that might also be helpful. So you can tell that they're actually not just relying on a couple instruments. They have a whole plan that they're unrolling here that began with microseismometers, now is with advanced seismometers, and next appears to be GPS, right? And all the time still using satellites. Also, they're doing outreach on Sunday. USGS and NOAA met with Department of Interior Assistant Secretary for the Office of Insular and International Affairs. Discussion included ongoing earthquakes at Ta'u, natural hazard monitoring, Pacific Islands, and ways to encourage local youth to become interested in becoming scientists. Certainly, you would prefer some Samoan adjunct to the USGS who knew all the local nuances and all of that, right? But USGS is doing great, as it is. On Tuesday, location constant. The team of seismologists is analyzing the earthquake data to narrow down where on Ta'u volcano the source is located. Did not receive any reports in the past 24 hours. However, 25 earthquakes large enough to be felt by people on Maunaloa Islands. Largest event, preliminary magnitude of 3. So that's interesting. You're having 25 earthquakes that are detectable that you think are in that threshold, but people are no longer reporting them. Maybe they're getting used to them, or they're maybe building some trust in the USGS that these are actually getting caught, right? Like they don't have to tell someone it's happening because there's an instrument already listening and knows that they're happening as well, right? So that's an interesting shift. We'll see if that continues or not. It's a little sociology thrown in here. Wednesday, yesterday, earthquakes constant, 28 large enough to felt by people, largest event magnitude 3. 1 earthquake reported to the Samoan Emergency Management Operations Center. Many small earthquakes detectable by humans still continue, right? And that was yesterday, and then we just saw the one for today, which is where they pinpoint more so these locations deep beneath Ta'u Island at shallower depths 6 miles to the north. So let's go back to our map. And our scale here, that's 3 miles, is about that far. So they're saying it's from deep underneath Ta'u to maybe somewhere as far as here, right? So maybe the range of earthquakes is something like that, more or less, right? We'll have to wait until they actually have everything calibrated and can plot them on a map. But based on the verbal description, that's where I would estimate them to be right now, which is not what we originally thought, not over here on this rift in between these two islands, but actually more so directly connected to this volcano itself. So fascinating. They do say, let's just review this, right? The shallower depths are to north, right? So there's still a chance of it coming out submarine, but to the north over there as well. Or it could just inject or, move the magma within the crust there and not actually cause it to erupt. But the question really is, how shallow are these shallower depths that they're talking about, right? Because deep beneath Ta'u is pretty, deep enough. It's maybe not directly connected to the shallower parts, but really how shallow are these shallower depths to the north would be my next question. So we'll wait and see. Interesting to see these day-to-day changes on Ta'u occurring here. So that is the update history, and I'm going to switch over here and I'm going to feature a blog from the Oikofuge, and I'm not sure if I'm saying it correctly, right? This gentleman lives in the United Kingdom, and you can find this website, oikofuge.com, right? And give this guy credit. But he has a couple posts that go back to February 2018 under his phenomena tag, and this is about the dateline. So he's done a whole review of the history of the dateline all the way up to 1900. Now I'm going to actually just scroll down here to the little section about Samoa. If you're interested in all of this, I encourage you to go and find this. I can maybe drop the link for Dane to share with you guys here, if you would like, Dane. There it is. So, Samoa in 1892. During the 19th century, the Kingdom of Samoa was keeping Asiatic dates, which had been established by the missionaries originating in Australia. However, Britain, Germany, and the USA were tussling for influence in the region, and in 1892, the Americans managed to persuade King Malietoa Laupepa that increasing trade from San Francisco would be well served if Samoa shifted to the American side of the dateline. And in any case, Samoa's longitude of 172 degrees west put it on the American side of the critical 180-degree meridian. So Samoa shifted from Asiatic to American dates by having 2 American independence dates in succession, repeating Monday, 4th of July, 1892. But the story wasn't over for Samoa yet. In 1899, shortly after Malietoa Laupepa's death, Germany and the USA divided up the Kingdom of Samoa between themselves, with Germany claiming the Western Islands, which at the time was German Samoa, and the USA dividing up in America the Eastern, American Samoa. So our volcanic island Ta'u is all the way here on the right, over here, right? We haven't even talked about any of the rest of what's now just plain old Samoa, and focus only on American Samoa, just this part over here. But just not far over here to the west is the other part of Samoa, once German Samoa, once the entire thing was the Kingdom of Samoa, right? So 2 colonial territories becomes relevant later. So I'll advance here to, there's a second part of this blog, and where's my section? It's lost. Okay, scroll out of view here. Okay, here we go. Samoa and Tokelau in 2011. So a little more history of Samoa here. From the start of the First World War, German Samoa passed into the hands of New Zealand as a Western Samoa Trust territory, and then became independent as Western Samoa in 1962. And then in 1997, Western Samoa changed its name to just plain Samoa, much to the annoyance of American Samoa, still the US territory, who felt that their neighbor wasn't entitled to the full unadorned title that had once applied to the original kingdom. All of it, all together. But right now, Samoa is just the western half of that original kingdom. So Samoa actually has shifted back across the dateline, east to west. American Samoa is only half Samoa that originally shifted from west to east in 1892. The shift was again calculated shift into alignment with the dates used by its partners. So basically what it's saying is now Samoa is trading with Australia and New Zealand more again. And along those lines, in 2009, they shifted from driving on the right to driving on the left side of the road, reflecting its ties to Australia and New Zealand. And so in 2011, they jumped from Thursday the 29th, and at midnight it became Saturday the 31st of December, just in time for New Year's, for them to be one of the first countries on the New Year side of the dateline, on the west side of the dateline. So connected, the New Zealand dependency of Tokelau, 3 atolls with a total of just 1,500 inhabitants, which lie immediately north of Samoa, elected to make the same calendrical switch on the same day. Tokelau's transport hub is in the island of Apia and Samoa, and his administration is from New Zealand, so that shift made a lot of sense. Interestingly, the Samoa Tokelau mission of the Seventh-day Adventist Church has refused to acknowledge the date change. This means that while the Christian churches in Samoa and Tokelau are holding their Sunday services, Adventist churches are simultaneously observing their Saturday Sabbath. A situation that's probably unique in the world. And that's the story so far. So that's I thought that was interesting enough and well done enough from Oikofuge. Come back to the top here, that I wanted to highlight this blog post of his, Territories Across the Dateline. And he's actually put together this graphic, right? So shifts in the dateline before 1845, all the way over. So it might be hard for you guys to tell, but if I zoom it in a little more, maybe not. So before 1845, so our Samoa is right in there. You can see that the dateline actually swings all the way west. It goes in Pitcairn and back east, goes around Samoa over here. So we're really interested in this little knob right over here. 1845 to 67, this part straightens up. We still have our little enclave here. 67 to 92, we adjust for Alaska up here to north. We still have our enclave in Samoa. 1892 to 99. It gets a little... that's when we pull Samoa out, right? It's hard to tell right in there, right? But Samoa's right in there, and we pull it out and just shift it to the north. And then you can see other changes coming in to 1900, right, where it's switching farther over, and that enclave doesn't exist at all. Like everything in the east here ends up being in a western hemisphere. And then the second phase of that slide here, 1900 to 1969, pretty standard. 1693, can't quite tell the adjustment there, but 1993 to 94, and here we are 95, we have that enclave coming back in here. And 2011 to now is when we adjusted this little section right in here for Samoa. So I know that's hard to see, therefore there is what it actually looks like. So there is Australia, there's New Zealand. In yellow, the dateline in 2011 as it used to exist, and in red as it exists since 2012. And Samoa right in between, right over there. Right now, this is fascinating because they actually drew the line between Samoa and American Samoa. So I found this NOAA blog post crossing the line here, and it's got the map of the time zones in the area. This is from 2017, so current. So let's zoom in on that map here. Load it up again, and this big red line right there, that's the date line coming over here, right? So zooming in, there is Samoa, and there is American Samoa, and the date line comes in right between the two, right? So if you're flying to American Samoa, you probably have to come into an area over here. If you come in from Fiji, for example, right, then you're going to be going across the date line to get there. So compared to the Greenwich Meridian time, Samoa is plus 13, Line Islands is plus 14, American Samoa is minus 11 right there, and then minus 10 is where we are here in Hawaii. And so there would be Hawaii, and then you can see all this and very weird goings on here, right? So this came about because I was wondering, I wonder what time that Samoan time corresponds to time in Hawaii, and you start looking into it, and it gets really complicated until you realize, okay, really, when it comes to American Samoa, yeah, it really is, right? I mean, in the end, you can say, okay, well, ultimately it's minus 11 compared to minus 10. It's only an hour behind us, but that's if you're really focused on only American Samoa. If you start looking at anywhere else nearby there, you're going to get in a world of trouble because it gets complicated, very complicated.
I can add a little bit more context for that potentially as well, because I think this runs into the war as well, the Great War. So at the very beginning of World War I, New Zealand occupied what was then German Samoa, the British. And at that point, New Zealand then continues to basically govern the German Samoa up until like 1960. So throughout World War II. So like it never got shelled by the Japanese, really. I think maybe once or something like that, but really went untouched throughout the Second War, which is rare for a lot of the Pacific Islands. But yeah, it getting lashed to New Zealand, I bet they were in no hurry to change the time back so it's a day different, right? Because it being on that timeline of New Zealand makes it right there just very little difference from them.
Right.
Just a little thought.
Yeah. So it really comes down to that. It's like, who do you trade with more? And American Samoa still has American ties, so they stayed in the Western Hemisphere, and then the rest of Samoa had more ties to Australasia, so they ended up on the Eastern Hemisphere, and the line is going right between them. But if you go, so here's what Samoa was pitching back in 2011 when this happened. They're like, you know what, you guys, anyone who wants to celebrate New Year's twice, come to Samoa, then take a boat over,
right,
and you can do it again. Like, it's really easy to get across the date line right there from one island to the other. So that might be what the tourism industry is promoting. Never looked into it myself until I came across this whole story. So, but that's the time zones of Samoa. There is one last thing on Samoa to do, which is show pictures, and then we'll wrap it up here. I know we've been going almost 2 hours, so quick Samoa pictures. Let's see here. This comes from the USGS photo and video release from last Friday, which had that first picture we showed you guys at the start of our broadcast. But most of this, and Lava Lake we showed you guys last week, most of this is photos of Samoa. So here is an afternoon view of the Tough Cone near Falesau Village, located in northwest Ta'u Island. And so you see that's that one we pointed at. The Tough Cone was cut by the ocean, and there's that point sticking out there. So there's Ofu Olosega Island, or that's what Ofu Island. Olosega is, I'm not sure which one it is, but they're both together back there. And there is that kind of underwater rift between them is right in here. And so where that eruption happened in the 19th century would have been coming out of the water through there. So maybe more off the picture to the right this time. So the tuff cone, which is thousands of years old, formed when hot magma interacted with either shallow groundwater or seawater. There are several tuff cones located within the northwest corner of Ta'u Island. And then we have a raspberry shake microseismometer that was installed on Ta'u Island. This is maybe the one that we're seeing the data from, might be this particular raspberry shake. There it is in its plastic case. We'll see it installed a little later. A view of the summit region of Ta'u Island and the Maunaloa Island group. So this is the top of that volcano, Ta'u volcano. Most of the volcano is under the ocean surface, and the exposed part of the volcano that forms Ta'u Island is covered in dense jungle vegetation, through which scoria cones are evident on its slopes. So these cinder cones you can see on the slopes as well. All right, a broadband seismometer is being installed on Ta'u Island near Fitiuta on August 23rd by the USGS HVO, NOAA, and with help from American Samoan government and local residents of Ta'u Island. I love this beautiful Polynesian lady's face here. She's smiling. You can see they're holding up the tarp because it's obviously hot, and there's giving the technicians some shade here to install a seismometer, right? And this advanced seismometers are actually embedded in the ground rather than kind of placed on top of it. So that takes a little more installation, and then of course you have to run all the wires. And we mentioned how power on an island comes from the big Tesla solar array and battery bank, so these kind of tap into that. But they also need to set up some computers somewhere to handle this data and process them, and use an internet connection somehow to get them back to Hawaii, and et cetera, et cetera. And so just one piece of it, but cool to see there. You see the ocean with waves splashing in the background. You can see looks like some ironwood trees almost there. Looks like not too unlike some parts of Hawaii here.
Or the Marianas. I mean, all the Pacific Islands it's so hard to figure out which one you're on. Yeah, it's the thing by the vegetation sometimes.
Right.
It's
yeah.
Real challenge.
You can see, the ground is kind of flatter and sandier, but that
yeah.
It's true a lot of these islands too, but not less so in Hawaii, which is on our island, which is younger, and you don't have as much flat ground like that right next to the water. So let's see here. Here's a second installation. Right there. See the USGS is like behind some building. Looks like it's got a satellite dish installed on it right there. So maybe that's part of their configuration. Who knows? But clearly, you need to get the data out somehow. And coastal view, south part of the western side of Nu'utele Island, off the west coast of Ofu Island and the Manua Islands. So they're doing a survey of the islands there, and this was something photogenic. Another tuff cone that's been eroded to form a little sea arch you can see through there. Okay. So all the layers are individual explosions that occurred. This is thought to be within the last 12,000 years, Holocene, and since then eroded by the ocean. More tuff cones. This is the one that contains both Faleasau Village and Faleasau Harbor in the northwest here. Similar kind of view. There's a raspberry shake seismometer installed at the Fitiuta Elementary School. There's one view of it, and then another view here installed in a school as well. And you can see behind the technician, look, there's George Washington. Clearly this is American Samoa. I got George Washington on the wall over there. So that's really all we had to share today. I know we've kind of gone on for a while. We're hit a 2-hour mark here. Do we have any questions, Dane, you want to get into?
No questions, but I did not shout out any of the super chats, so I want to take care of that real quick. We appreciate everybody that showed up and threw a little bit of money our way. It really helps. First one was from Chris Kiki, who said, "Thank you, Phil and Dane, for your knowledge and keeping us informed. You're very appreciated. Appreciate the support there, Chris." And we also had Lisa Lynch come through, say, "Hi, guys. Go Steelers," with a $20 super chat. Appreciate that. I don't know if they're playing tonight. Thursday night football, maybe.
I think she says
it
says it's just routinely, like all the time, go Steelers.
Yeah. getting that time to be football season again. Gary Bryan comes through, a longtime supporter. Thank you so much, Phil and Dane, for your prep and analysis. All goes into these updates. Appreciate Gary as always. Good to see you again. And then we had where is it? A $5 super chat from Benjamin Fairhall, who says cashed up this week. Thanks for your efforts, guys.
My lagging.
Our new kind of supporter. I'm not sure. I think it's.
So if I'm lagging, it's possible Dane lags too because his feed comes through mine here. So you might want to repeat that, Dane. That's all I'm saying.
I'm not sure what I need to go back to. I think I'll just the Benjamin Fairhall super chat for $5. Appreciate that one. But we also have a new kind of supporter. We landed the 5Y grant and aid from Hawaii County to help continue support this type of content, as well as more content in writing, short videos. We're going to be going for the next year pretty hard in terms of all the content that we're going to be bringing you guys, a bunch of educational volcano-related content for Hawaii Island. So we're really appreciative of that. But that's, really helps us to continue to do what we do, but also expand it, make it a little better, try and get a little bit more set up for the next eruption, and that's going to be what we're doing for the next year. So yeah, really appreciate County of Hawaii coming through on that one.
Yeah, for sure. Mahalo, County of Hawaii. Yeah, and if you guys have been watching us for a while, we'll kind of pick up what we were doing last fall, right, where we were putting out short videos as well with summaries and written articles that summarize in case you don't have time to watch a full live 1 week or another. You can catch a short video or maybe help review it or share it with your audiences as well. So thought we'd just announce that coming up, and so we're excited about that. Look for that starting next week.
I mean, the county's basically enabling us to do this full time for the next year with the support that they've been throwing us, and we really appreciate that. And I think we've been able to show how important it is that this type of information continues to go out, not just in the times of disasters, but before the disaster happens.
Right. Our real goal is to leverage education here, right? All this interest, all the fascination, all the cool stuff that's happening into preparedness, right? The more we know about the volcanoes, the more we'll be prepared to respond to them and to help others respond to them, and to not be shocked when something happens, when it actually is happening, to be able to spring into action as needed, because a lot of action is going to be needed when that time comes, even if it's 20 years from now. We hope it's 20 years from now, but especially if it comes to Maunaloa, a big volcano that affects people that aren't used to. And I have a couple.
Very much. So really appreciate that.
Any more thank you, Danes? No, did he freeze on me? I think I'm having some issues. You got any more thank yous, Dane? No?
Hope you're back now. One last thing. I think they were done with the thank yous. I did do a little poll just for fun. We had 43 votes on it. Question was, do you think Maunaloa will erupt in the next year? Yes, no, and no idea were the options. We had 23% say yes, 41% say no, and 36% say no idea.
Yeah, interesting. Very scientific of our audience.
Sorry guys for the lag. Seems like we're having a little bit of it right now. I'm glad we got through most of the stream. We're just at the end now. Before the lag kicked in.
Yeah. Sorry if it's getting bad here, but one last thing I have to show is just to mention that the flights, the AEM flights in Puna have been ongoing. As our kind of our community corner here that we haven't really done today. So let me see if I can put that on the screen here. But you can see that there are no more dates posted, but there were flights August 24th, 25th, and 26th. The 26th was a couple of redo flights, so I'm not sure what's going on with that, but we haven't seen any new postings. But this is a page, keep your eye on that for ongoing flights. Did want to mention that the National Park has issued events for September 2022 in this release. So there's all kinds of things going on. I'll kind of try to keep it short here, but they have walking a pack with Dr. Thomas A. Jagger, with our friend of the program, Dick Hirschberger, dress in period costume reenactment of Dr. Jagger in the Whitney Vault. Fantastic. Most Fridays, 10 a.m. and noon. So check that out. Not 23rd in September, notably. There's stewardship, also most Fridays, one Saturday, to help remove non-native plants. There's the After Dark in Our Park series is coming back, which is usually Tuesday evening, 7 p.m. in the auditorium in a national park. So the first, and usually not the first week of the month, but the first program of the month will be Tuesday, September 15th, about the dark skies of Hawaii. And there will be a sky advocate showing 4K images from a James Webb telescope on a big screen, and an update about the National Park's mission to become recognized as an international dark sky park and how you can help track the telescopes, that kind of thing. There is an artist program on the following After Dark, September 20th, a fee-free day on the 24th of September. But really, what I'm trying to get to in all of this is this 2 paragraphs right in here, which is that Eruption anniversary. September 29th is the anniversary. And on that week of Eruption, that Tuesday on the 27th, there will be a program by David Phillips, summarizing latest science images and videos of this eruption in Halemaumau. So that'll be the anniversary talk on Tuesday. And then an actual Thursday, a month from now on the 29th, they're going to have a 1-hour talk on the edge of the caldera with USGS scientist and Hawaii Volcanoes National Park ranger, sharing highlights of the eruption and Hawaiian cultural perspective. That'll be 3 p.m. Hawaiian time on Thursday at Uikahuna. And our plan is, you can mark it now, we're going to try to do a joint stream with 2 Pineapples from Uikahuna and stream this event for you guys, and then switch into some reaction afterwards live from the spot. So that's a kind of a unique event happening for us here. So if you happen to be on the island and want to come check it out, you can come out and meet us and see the broadcast on that one time, and meet 2 Pineapples too, that kind of thing. But we'll likely not be having a regular update on that day, and we'll talk about the details of that coming up in the future as we approach it further as well. But just heads up, if you are in the area and want to plan for Thursday 3 p.m. Come up to the park, that we're going to be doing something unique at that point on that day. So elsewhere on this update, there's Kahuku programs over on South Maunaloa and other walks in the national park as well that are recapped here. But we'll leave it at that for now. We'll review this once again next week. So one last thing, you can look. We may have an unscheduled stream coming up in the next week, perhaps, if we can get our associate Ikaika Marzo to come on live. So we'll see if and when that happens within the next week, but keep your eyes out in case that does happen on our channel as well. So that is finally it. And finally, I can stop talking, Dane. Let you say some goodbyes, and I'll say mine. Oh, I can't hear you. You still coming through?
There we go.
Okay.
Yep. Yeah, thank everybody for turning out. We rely on viewers like you for the continued support. Not only that, just to get this message out to more people, right? That's the real thing, is trying to get the real information to as many people as possible. Try and get the understanding up, because really that is what resilience kind of looks like, or prepping. The beginnings of resilience is understanding what you're going to deal with, right? At least the confines in which you're expecting it to operate within, right? Reasonably. Otherwise, you're just like, you have no idea, and you're shooting in the dark. We kind of got lucky 2018 shooting dark, but we don't want to be doing that again. And it's really, we're not going to be letting those lessons from 2018 go to waste, really. But yeah, that'll do it for me. Jump in again next week, 5 p.m. That's our normal stream time, 5 p.m. Hawaii Standard Time. If you share, like, subscribe, that definitely helps the channel grow and get more views, all that kind of stuff. But yeah, we really appreciate you guys. Until next week.
Yeah, for sure. Mahalo, Dane. Yeah, and to kind of reiterate what he said, like, the way I see it is we're building an army, right? You guys are all part of an army. We're all in an army that even if you're on an island, if you're not on an island, we can all respond together. Some people can help digitally, others can help in person when the time actually comes. We can all help educate our neighbors and friends and bring them in the fold and kind of grow our army and our movement here, right? But like when the time comes, we're going to ask everyone for help, sharing all the stuff that we're talking about now, right? Because you guys are A students here listening to this every week. You're 2 hours and 12 minutes in still, so I know you guys are the ones. So that said, like Dane, appreciate you guys, and until next week, from Hawaii Tracker, he's Dane DuPont. I'm Philip